Previously, we covered the core foundations. Now in part 2, we tackle how two rival teams proved a black hole sits at our galaxy's center. Part 2. The star that nearly grazed a black hole. S2's 2018 Close Pass. Orbital Dispatch. Narration Script. Nobel. How two rival teams proved a black hole sits at our galaxy's center. Canton Falls. Part 2. The star that nearly grazed a black hole. S2's 2018 Close Pass. Hook. By 2002, astronomers had tracked a star called S2 through a complete orbit around something invisible at our galaxy's center. But tracking an orbit is one thing. Proving what's actually causing it is another. Intro. Recap. Bridge. In the previous episode, we looked at how two independent teams, one led by Reinhard Genzel in Germany, one by Andrea Ghez in California, spent the better part of 3 decades mapping stellar orbits around Sagittarius A. Those orbits pointed strongly to a supermassive black hole. But this episode is about the moment the case got tighter, much tighter. The core question here: when S2 made its closest pass to Sagittarius A in 2018, could we detect effects that only general relativity predicts? Effects that Newtonian gravity simply cannot explain. Section 1. Setup. What made 2018 special? S2 follows a highly elongated orbit with a period of about 16 years. At its closest point, called Pericentre, it swings to within roughly 120 AU of Sagittarius A. That's about 120 times the distance from the Earth to the Sun. For context, that's extraordinarily close to an object 4 million times the mass of our Sun. This Pericentre passage was predicted years in advance, and teams around the world prepared for it. The European Southern Observatory upgraded a key instrument specifically to capture this moment. Gravity, an interferometer that combines light from all 4 of the VLT's main mirrors simultaneously. By linking those 4 mirrors, gravity effectively behaved like a single telescope with a mirror 130 meters across. That level of resolution was necessary because what they were hunting for was a very subtle signal read in S2's light. Section 2. Discovery. The Gravitational Redshift. As S2 plunged towards Sagittarius A, its light had to climb out of an extraordinarily deep gravitational well. General relativity predicts that this should stretch the wavelength of that light, shifting it toward the red end of the spectrum. This is called gravitational redshift. The gravity collaboration measured exactly that. The spectral lines of S2's light were shifted by an amount that matched general relativity's prediction to high precision, and that Newtonian gravity, on its own, cannot account for. This was not a marginal detection. The signal stood clearly above what pure Newtonian models would give you. The result was published in Astronomy and Astrophysics in 2018, and it represented the first detection of the specific relativistic effect at the galactic center. Section 3. Implications. What it ruled out. This matters beyond confirming what most physicists already suspected. The precision of the measurement allowed the team to constrain, and in some cases rule out, certain alternative theories of gravity that had been proposed as modifications to general relativity. Theories that might otherwise have remained difficult to test in this regime. It also reinforced something important. The object at the galactic center is not just very massive and very compact. It behaves, in the way it warps spacetime, precisely as a black hole described by general relativity should. The result contributed directly to the body of evidence that led to the 2020 Nobel Prize in Physics being awarded to Roger Penrose, Reinhard Genzel, and Andrea Ghez. Closer plus handoff. S2's 2018 flyby gave us something 3 decades of orbital data alone couldn't. A direct imprint of general relativity on light coming from the galactic center. The black hole wasn't just inferred, it was felt. Next episode, Part 3 explores the next key question. What came after the Nobel, and what the ongoing observations of S2 and other S stars are now telling us about the environment around Sagittarius A. Subscribe CTA. If you'd like to follow the rest of this series, subscribing means you won't miss the next part. Thanks for watching Orbital Dispatch. Episode Guide. Part 1. Mapping the Orbits. Part 2. S2's 2018 Close Pass. You're here. Part 3. Coming next. If you have a question about gravitational redshift or the gravity instrument, drop it below. That is part 2 of how 2 rival teams proved a black hole sits at our galaxy's center. In part 3, we explore the next key question. Subscribe so you do not miss it.